Good morning, good afternoon, everyone. Welcome to February's Power Hour for TBC. Today, we'll be talking about BIM for land surveyors. And I'm joined, go ahead and advance the slide. I'm joined by not one, but two guests today, Fernando Calvo and Boris.
Hello, everyone.
I'm Joe Buck. I'm the TBC product manager. Want to thank you for joining us today. And you're in for a treat because I will be talking almost not at all and letting people who know much more about this subject give you a nice introduction and how you can leverage BIM workflows for your land surveying applications. So thank you for joining us. And with that, I'm happy to turn the presentation over to Fernando.
Okay, thanks so much, Joe and Boris, for the invitation. And I'm glad to be here today to exchange with some of the users worldwide, some of our workflows. And hello, everybody from Germany. And I'm Fernando Calvo. So I'm a land surveyor. I come from Madrid, from Spain, and in the last 20 years, I have been having different positions around Europe. So as land and build surveyor, software developer, so in sales, product management, etc. And since 2015, I'm running Calvo Geospatial Consulting. So we are focused on especially consulting for land survey, GIS, BIM, and civil engineering. And we are also developing some customized solutions for under Trimble Access, AutoCAD, Civil 3D, Revit, and SketchUp. And we also offer some trainings about Trimble solutions, but also some Autodesk and Esri solutions. At the same time, we work with some partners around Europe, so creating some scan to BIM models, and it helps us for the development. And therefore, I have decided to create today a very practical agenda. So based on our experiences in the last more or less 15 years in 3D modeling and BIM modeling in the last few years. And I hope that it can help you to pick a couple of ideas to optimize your workflows with different software solutions, but obviously focus on the great help that TBC can offer to us. After a very quick introduction about what is BIM, I will continue showing you some of the workflows that we can follow, field to BIM, but also BIM to field. And after that, I will show you a live demo of the building app that we have developed for Trimble Access. So you can measure with your total station and create automatic 2D, 3D, and BIM models in the office, in TBC, SketchUp, etc. And after that, we will do a quick summary about the main goals and main ideas that we could cover today. And after that, we will make some questions, answers, etc. But you can place your questions during my presentation. Some of them could be asked during the presentation. So as I said,
Fernando, sorry, just to expand on that point, if you do have any questions, please go ahead and type them in. We do see them all, and we'll interject with Fernando if they're applicable. If not, there will be time at the end to discuss it. And if we don't get to any questions, we can reach out to you and follow back up with you. So,
okay, thanks. Yes, so let's start just seeing what is BIM, the principles of BIM. So probably you have heard a lot about BIM, and if you ask 10 people, you will get 15 or 20 different answers. So I'm trying to focus on what we need for a survey, but let's start first with main principles. So many people say BIM is a software. Many other people say it's a 3D model. Many other people say it's a database. So it's actually all this, but even much more than that. So it is a whole process which contains the design, the construction, execution, and management of buildings, but also infrastructure. So you know, BIM is building information modeling. So it was developed for buildings many years ago. But probably you have also seen in your countries there are some BIM projects for infrastructure, for civil engineering. So the BIM model uses intelligent objects, is geometry and data. So it is what you know for example, from GIS. It's geometry that you can pick and polylines and areas, etc. But all this geometry has linked in data, metadata, and attributes, properties, etc. So the goal of BIM is that all project involved parts can collaborate and communicate. This is the key of BIM. And obviously, in order to do that, all disciplines need to work on the same building model. This is an open point. Depending on the country, we can discuss the solutions that we can use. But there is also so nowadays some people still work without a central model. But it is the goal, the goal of the system. And in a summary, so BIM is all about the I of BIM. So it's information, it's intelligence, integration, and interoperability. This is the key factor that BIM differentiates from building modeling, from the 3D that we are used to see, or we were used to see many years ago. So then moving a bit more about the principles. So you all come from different countries all around the world. So the BIM implementation is completely different from country to country. There are some advanced countries so in Scandinavia, all countries in Scandinavia, so in the UK, in the US, and Australia, they are pretty much advanced. And for example, in Scandinavia or in Finland especially, they started back in 2007 with the BIM implementation. But there are other countries like in Germany, where I'm based, so it will be mandatory in 2020, the same like in other countries all around Europe. So as I said, the central element is the building model, the building information model. So all the parts, the owner, the architects, civil engineers, structural engineers, MEPs, or mechanical, electrical, and plumbing engineers, and the builders and fabricators can access to the same model, and any change that is made from the planning, from the design, from whatever is automatically updated. So for us as surveyor, we could access to the current revision before we go to the field to stake out the walls, columns, etc. So this is the main idea. And also probably you have heard a lot about dimensions in BIM. Obviously we are moving ourselves here in the 3D geometry dimensions, but there are also some more. So it's important for you just to have heard it at least once. The 4D up to 8D, the time, the cost, the facility management, sustainability, and security. But probably the most important for us, obviously, it's 3D, but also the 4D and 5D, because there are some software solutions that you will use in the near future, or you are already using them, which make use of the 3D geometry and properties that we are providing in the BIM model to make some timing and cost estimations. So for example, if we provide a whole building as a BIM model, and the company, our contractor, can make a query to the system and ask how many windows have to be changed in 10 years of levels 0 to 10, and how much would it cost, and how would it be the timing to bring each amount of windows to the site in order to be mounted, all of them. So it's very related, so the geometry to the time and to the cost, and therefore so that we can make better decisions, and probably not ourselves as surveyors, but it can help the next part in the chain to make better decisions. And especially for surveyors, so BIM has a lot of elements, which belong to the model. But actually, as surveyors, when we go to measure a building, so with traditional methods or laser scanner or whatever, what we are seeing is just about a maximum of 20 to 30 elements. We are seeing on-site walls, windows, doors, so columns, roofs, etc. So this is exactly what we need to measure and to modelize. So obviously we don't see the cables behind the walls, and it also belongs to the BIM model, but this is not our main task. Therefore, I would like to focus today on the elements that you can find in this case on site. So Another point, so just a couple of slides and we are done with the introduction and we move to the practical part. So also important to know is what is LOD and LOA. So once you get the project requirements or the tender specifications, you will always see these two words or letters. So LOD is the level of development, which really means the level of detail that you have to provide your models with. So depending on the country, we have different levels. So between 100 and 500, or in the US, for example, you have an additional one, 350, or there are others between 1 and 4, but it means the level of detail. So in our case as surveyors, we are requested mostly to deliver between 200 and 300, which is the real dimensions of all elements, walls, windows, etc. And in some cases also with materials or not, so it also depends of the project requirements. So, but mainly what we can see on site, obviously we cannot see the layers of the wall, so probably we are delivering a mix between 200 and 300, but as I say, it depends on the project requirement. And also important is the level of accuracy. So in each project specification, you will see the level of accuracy. You see here the levels that we can find. Also, probably depending on the country, you could also see a slightly change so levels. But you will see, for example, for the topographical survey outside, the LOA is 25 millimeters. So you can decide, okay, I can measure outside with my GNSS receiver because I'm achieving better accuracy than 25 millimeters. And then for inside, you will get so 1 centimeter, 2 centimeters, whatever. So then you can decide, okay, I will do it with a total station, or I will do it with a laser scanner, or whatever. So these the two things that you have to know about BIM, especially about the requirements. So you will be on a better position to understand what is requested.
So Fernando, you're saying if ever you decide to bid for a BIM type of a project, the first question you ask the general contractor would be what is the LOD and LOA required, right? Because the quote is going to be much different.
Exactly. So also depending on the project, as I said, so in some cases LOD 200 is enough, but in the most of the cases, in many countries, you have to help your architect, your customer to decide which level of detail, because obviously ourselves as surveyor cannot provide LOD 400 or 500 with materials, with energetic values, etc. So depending on that is the time that we will require for the model and for the 3D modeling, etc. So these 2 points are key factors for you to calculate your time.
Is there a standard, or is there somebody who creates these standards on a national or regional level, Fernando, or it really depends from site to site? It's a question that came in from Jason Weiss.
Yeah, so it's country-wise mainly. So each country is developing special standards for BIM and BIM implementation and different levels, level 1, level 2. But it is mainly, as I say, country-based. But you could also find a variation inside a country. And for example, imagine that we have in Germany these 5 levels. And you get in the project requirements, we want LOD 300, but additionally we want the U value, it is an energetic value of each window, because it's needed for the energy calculations of the whole building. So, but mainly the main question is country based decided.
Thank you.
You're welcome. Okay, so then we would move to the next slide, and I will ask Boris to tell a couple of things about the life cycle.
Yeah, so this diagram serves as a visual representation of how we view the building life cycle here in Trimble. So at every phase, we have Trimble solutions that contribute to the success of the building construction process. So the process really begins with the plan, and we have solutions from our real estate group that provide customers with planning tools to determine strategies for buying, leasing, or building. So when the decision is to build, the concept phase gives customers the tools to create and visualize designs in 3D, to take a more detailed design process and provide constructability to a concept. So once we have the full detail, design becomes construction ready, and it goes for award to specialty contractors like MEP or steel or so, and the construction process begins. So at the end of the project, the final building is ready to be fully operational and managed for optimal utilization. And even that in that stage, so for the entire life of building, Trimble solutions allow for full utilization and support retrofit refurbishments and additional optimization as ready. So Fernando, if you advance to the next slide. So this slide shows you some of the solutions that you might be familiar with, some of the software packages that Trimble has either organically built or acquired over the years. So you most likely have heard about SketchUp, Tekla, Vico potentially. So these are all very known names in the building construction industry. So what I don't like about this slide, it fails to mention Trimble Access and Trimble FieldLink and the role of the surveyor. So I really want to stress out the importance we as surveyors have in this project lifecycle. Before the design can even start, you have the surveyor on site collecting current topography or building as-built. So sometimes even during the proposal stage, you have surveyors doing some quick measurements or data collection for preliminary design. During the construction process, we are present for staking out and quality control and verticality checks and floor flatness and things like that. And then even in the building demolition process, you have a surveyor going in and measuring the structural elements, for example, to understand how you want to demolish and remove the building. So I really want to stress out that each of these here life cycle data points or entry points is an opportunity for a surveyor to come in and offer services and be present in this entire life cycle. And from the Trimble perspective, we have that Trimble Connect in the middle that really acts like a glue between our solutions and allows a user of SketchUp to interact effectively with user of Tekla and interact with the field devices and get data from the field and the office back and forth. You want to go to the next one? So there's a lot of interest recently we've seen in Microsoft HoloLens. This has been an interesting development. We even seen Trimble Business Center users exporting data prep information to Trimble SketchUp and using SketchUp Viewer for HoloLens to communicate, and so multiple participants can look at the model as shown in the top right image, or even on site with Microsoft HoloLens. You can have that model preloaded, and you can visualize how the elements are going to fit into the existing as-built scenario. So again, going forward, you will see Trimble Connect being more important for our workflow for TBC and connecting TBC to Trimble Access, but also to other Trimble solutions.
Okay, thanks so much, Boris. So we would go to the next slide, and we'll start checking the kind of workflows that we can use field to BIM. So measuring as-builts and bringing it into the BIM world. I want also to let you know, or to stress the fact that we are talking about BIM, but there is a lot of and a huge business also for 3D. So in the countries where you are not using BIM now, so there is also a huge business for 3D modeling. So therefore, we are trying to help you to get these much quicker 3D models, because it's the time-consuming part. So the data collection is so incredibly quick and easy to nowadays with the new instruments. So we are trying to help you with the next step. So one of the workflows that we would like to show you today is measuring with a traditional total station and the building SEP that we developed. So you are measuring, as I say, with a Trimble total station and with Trimble Access that you know because you are using it for your current field work. And we have developed special masks to measure walls, windows, etc. that we will see live in a couple of minutes. And after we have finished the measurement on site, so we can go via TBC, so we could get 2D, 3D automatic drawings. And from there, we can also create with the drafting module, you can create your deliverables, print to PDF, print to paper plans, whatever. But in the cases where your contractor needs a different or requires a different result, you can also export directly from TBC to DWG or DXF. So you could go into any kind of CAD package, or you can also export directly to SketchUp format, so you can continue modeling in more detail the 3D definition of the building. We will also see it in a couple of minutes, or you could even export also to DWG, for example, and import this into Revit, so we could create the walls, the windows, etc. Okay, this is an example with Revit, but you can do the same in Tekla, in any other BIM software. And the way how we go to the BIM world from this line is via IFC. So IFC is the standard format for data exchange. It has been on there for many years. So there are hundreds and hundreds of IFC objects, and this is a kind of DXF for the CAD world, but for the BIM world. For buildings, there are hundreds of elements of IFC, but for civil engineering, at the moment, so far I know, there is only one element, which is the axis. So therefore, BIM or data exchange for BIM for civil engineering will need a bit longer, but there are a lot of pilot projects, and the Building Smart International is working really hard to continue with this development. This would be from using a total station and the building set, but also there are many people measuring as-builts with laser scanner, or just using point clouds coming from different data sources. We are especially using the TX8, but also TX6 or the SX10, or even the TIMS, the Trimble Indoor Mobile Mapping System, which is also offering amazing results, and in a very quick and short time. And we can do the same way. So the data itself is a point cloud, also with some pictures or panoramas or whatever, but the point cloud is our geometrical information, and we can go through TBC with the latest point cloud capabilities, so for classification, so segmentation, and whatever. So we could just draw in 3D inside TBC, picking on the point cloud, and then once we are ready with the 3D definition of the reference that we need, either we can deliver it as it is, or we can go via SketchUp or via any kind of BIM software like Revit, for example. But we could also import the point cloud inside RealWorks, Trimble RealWorks, so we can also create very highly detailed 3D models, even in this case, even in real time, so connected to SketchUp. So we can click on points on the wall, and the wall is created in real time on the right side inside SketchUp. So there are different ways that we can follow. So therefore we try to summarize the ways that you could use, and I hope that you identify yourself in some of these workflows. So we will see some of them right now.
Hey, Fernando, yeah. we have a question from David that is relevant to this slide. Where do you see UAV photogrammetry contributing to the common data model used in BIM?
Yes, so UAV is also very extended for BIM for infrastructure. So many companies that I know are using UAVs to fly along, so especially linear civil engineering objects or projects, and then they are this is at the end of the day, this is also a point cloud, so we could use any of them. So I have done some project with the ZX5, for example, importing the data in TBC with the aerial photogrammetry module, and we could create our topographical surveys or calculate different between volumes during different phases of the construction, and this data was coming from a UAV. So it's also very much used for the construction side.
Yeah, so I guess the point is that the BIM doesn't just mean within the walls or enclosed by the walls. BIM is everything around the building as well. So therefore, UAV has a strong application in the BIM environment.
Exactly. So as I said, for civil engineering at the moment, so they are the independent BIM software packages that can work with corridors, etc. But at the moment, there is no standard IFC for the whole civil engineering project. It's only for the axis. So you can work BIM based inside each of these individual software packages. So you are producing BIM. But what I mean for the data exchange is not possible at the moment, only for buildings via the IFC. But obviously you can create BIM models also of topographical elements. So for example, via Nova, this is also a Trimble product. It has a great solution for civil engineering. So you can define your corridors, your sewers, your every kind of element that you can find along the road, and it's BIM based, and you can also work with exporting line XML, etc. So it's a very, very good solution.
I guess also in the building space, Yari commented you can use it for roofs or facade reconstruction, right?
Exactly. So as I said, so in BIM we have different elements in the whole model, and everything is specified. So for the facade, in our case, each wall in each so it's a kind of structure. We start with the side, then below the side is the building, below the building is the floor, below the floor the wall, and inside the wall the windows, the doors. So there are also a relationship between the elements. I cannot place a window if I don't have a wall. So therefore, you can also create facades and everything, but also it has to fit and suit inside a BIM object, a wall, a window, a door, etc. A roof, so staircase, etc.
Thank you.
You're welcome. Okay, and then we would have the way around. So bringing a BIM model to the field. We have different ways. Obviously, we would like to show you today the way using Trimble Business Center. So we can pick any IFC file. Again, this standard format that every BIM software supports for import and export. Also SketchUp, for example. So we can pick this IFC file, import into TBC, and then export for the staking out process to Trimble Access. So we can create inside TBC the corners, the points that we need to stake out, and then it's a very quick process that I will show right now. Before I show this, I would like to show the next one, and probably Boris knows it much better than me. Probably you can say a couple of words about Trimble Field Link.
Yeah, so for most of the participants on the call, you are familiar with Trimble Access, but I do want to say that if building construction is what you do for a living, and you may want to kind of look into the Trimble Field Link. It's a field software optimized for field data stakeout, particularly for buildings, with a direct support for IFC, so you can visualize the model. So it's much more map driven in that context. Doesn't have all the survey nuts and bolts of Trimble Access, but it's a very easy to use field software that's particularly targeting building construction professionals, and it communicates with Trimble robotic total stations using building constructions, the RPT instrument here, but also supports Trimble GNSS product line, and there are few plugins with which you can communicate with major packages and get data in and out of the field for example, hangars or duct runs or any other MEP or general construction type of stakeout.
Okay, thank you. So I would come back to this slide. So I will show you right now using Trimble Business Center how we can open an IFC file and prepare the data for the staking out. So I'm changing to TBC. just open an empty file, and then I just import one IFC file which contains some columns, walls, etc. So, and for example, our next task is to stake out some columns from the ground floor. So we see here the 3D right now. So you see it's a whole building, so it was very quick to import. So then we can just go here to the left side to the layers, and you see that everything is classified. So IFC BIM column, for example, we want to leave only the columns, and we have to stake out, for example, this column from this area. So we can just prepare it using the CAD functionality, create point from CAD, and we just select so the point number that we want to start with, etc. And that's it. So we click on apply. So we have the points there. You see at each corner, and it would be a very easy task just to close this, select the points that we want to export to Trimble Access, for example. We can also export to CSV or whatever. So we just create the file inside my project folder. So this is TBC and export. And then we can go to the field, open Trimble Access, and we open this file. And we have the information there. So the points and also the background if we want it. So we see the points, but we can also load some layers. For example, if we export the IFC to DXF, so we can load this data there. I think it's this one. So you see there, we have also the columns themselves. So we can pick, even activate the layer of these lines and pick the line and stake out the line. So it's a very quick process to go from BIM to the field for the points that we need. So it's
the functionality that Fernando just showed in TBC is licensed to the TBC Advanced Edition. And a question has come in. Fernando, the IFC that you imported, what version of the IFC file is that? What version is IFC supported in TBC?
Yes, at least this version was 2x3. I'm not sure if version 4. So in general, there are two versions of IFC, or there are an older version, but at the moment, everyone on every software uses 2x3 and 4. But most of the software packages support only 2x3. Therefore, I would recommend to use 2x3. But I'm not sure if TBC also supports the version 4. So I can
2x3, yes.
2x3. But this one was 2x3. And so I have worked at the moment only with 2x3 because I also request and get all the data with 2x3 because of this issue that not all software package, even Revit or some others, they don't support all formats of IFC. But 2x3 is the one supported by all of them.
Question from Jaron was if we have the creation of those IFC files and columns within TBC, and as Fernando said, in TBC you have the ability, for example, from the as-built data to digitize or kind of draw the geometrical elements, but TBC doesn't have the ambition of being the engineering CAD or BIM design software package. So our mission is really kind of more along the lines of streamlining interaction and allowing you to see that BIM information along with any other geospatial information that you have in TBC.
Yes, exactly. So TBC is helping us a lot to bridge some gaps and to connect some BIM software to the field software and the way back. And therefore, in the next step, I'm also showing the way back, so from field to BIM, and TBC is helping us to reduce the manual modeling. So therefore, BIM, the TBC is obviously not a BIM solution, but it's helping us to use some workflows to optimize and accelerate our steps as surveyor. So we are using it, and we are really happy with the advantages that TBC can offer. BIM. But it's clear it's not a BIM solution. We have some others inside Trimble and also externally. Okay. Can you hear me?
Yeah.
Okay.
Please.
Okay. Very well.
Thanks.
So I showed this one. So we are moving to the next point because it's a lot of stuff that we would like to show today. So we are showing now the building SEP for Trimble Access. So another practical thing. So this is what we developed it because many customers worldwide are still measuring with total station, and in some cases, or for smaller to medium projects, you are quicker with the total station, and especially we try to optimize and accelerate this manual modeling. So therefore, we developed this solution. It's a quick and intelligent building software solution under Trimble Access, and we support different workflows because we acknowledge that each of you work in a different way, and each contractor requires the deliverables in a different way, the XF, the WG, or TBC format, or the DWG, or even SketchUp, or whatever. So it was important for us to enable a customizable 2D representation for customer needs. Therefore, we will see it right now. We can measure with the same software outside. So the goal is not to produce a finished drawing on site, but to be as quick as possible. So we know that our system, our solution will provide us the finished deliverables with a couple of clicks. So after we measure, we just can go via TBC and create 2D and 3D with 3 clicks. Or from TBC, we can export the DWG or DXF to any CAD system. We will see it right now. Or if the project requirements are to create and deliver a full 3D model, we can also use the plugin, our plugin inside SketchUp, so we will get a close to finished 3D model. And from there, we can move to the BIM world again via IFC. So we are talking a lot about IFC because it's the standard. So now I'm going to show you first the building SEP itself, so how we can measure the room where I am with the main elements, just to show you the main functionality. And after that, we will import the job XML file into TBC, and we will see that we will create 2D and 3D automatically. But also for some of you that need to deliver this in a different format, or we will export to SketchUp. So, and then we will continue modeling inside SketchUp, and we will export to DWG. So we will see how it's coming to AutoCAD, and also in the cases where you need to use Revit or any other BIM software, how we could continue from the data that TBC produced. And finally, importing the job XML file inside SketchUp, so we will get a full 3D model with automatically. Okay, so just then I'm changing to Trimble Access again. So you see here I have different apps that we develop and some more. So we start the app. So you see here the surface. I'm putting a different background so you can see it a bit better. 1 second. Okay, this one. So you see we start the app and we have a very easy structure: jobs, walls, openings, columns and beams, symbols and tools. As simple as that. So we will start measuring, creating a new job, also customized to be quicker on site. TBC 1, 2. So we choose the units. So it's everything that Trimble Access can create. And we could even start the customization from here. So we can say, obviously, the language that we want, but this would be the prefixes that we will see in TBC for the floor height, the ceiling height, etc. So we don't change it, and we just start measuring. So I just change to laser. I just change to laser, sorry. Now, and then we start just measuring the walls. Obviously, you can use any stationing setup that Trimble Access offers. I just do a a local one, so with 100, 100, and 10, for example. So we can start measuring. This is the target height as 0. And then you see here, we can choose the floor where we are, the room where we are, corridor, bedroom, whatever. This is customizable, everything. And then we choose if the room is closed or open, and if we are measuring the corners or we are measuring 2 points per wall. So we are calculating the intersections. So I would start, in my case, measuring 1 point on the floor and 1 point on the ceiling. So we are able to calculate the wall height, and from now everything that is measured as a wall will have this height. We measure a point on the ceiling, and then we start measuring the corners. We have a few corners here in this room. So you see it's like a street light. So green, red, etc. So it says to you, you can measure the next point, or you cannot measure in red, or it's optional in orange. So measure in the next one, a couple of points more, and then we close the room. If we don't see any corner from our current station point, we can also change to the second screen. So then we would use the distance meter, and we would say to the left, to the right, or whatever. So I measure the next one. We check it here, everything that we are measuring. But as I said, our goal is not to have a whole drawing on site, but just to be as quick as possible. And we are recording in the background a full BIM database. So the last point, let me check. Yes, the last point, and then we close the room. Okay, so we close the room. We have our room there. Don't pay attention to the representation because it's depending on the codes that we are using. So then we have the walls. We would move to, we can do a new setup, a resection, so add new control points, but the next step would be to measure the openings. So we can choose the door first. We are in the same room, so therefore we just measure the wall thickness and then choose the type of wall that the type of door that I'm going to measure. So you see there the points that we need to measure. In my case is a single door opening inwards and to the left, this one. So I measure a point on the top, one point on the left, you see it, second point and third point, and then we have our door. I'm not getting the measure back. Probably is too close. Let me come back and choose and pick another point, not so close. Okay, so you see there the height of the wall, so we can check if we measure the right point or behind the door, for example, and then left point and right point, we will have the width, and at the same time we will get the representation in the drawing. And this is the same for windows, for staircases, for any kind of objects that we can see. I'm hiding the names so we can see it a bit better. So you see that the door is opening in the right direction. So, but as I said, don't pay too much attention to the representation on site. So for the windows would be the same. So we choose the type of window. It's a normal window or it's a window with retainer, and the number of panels that we can find. Depending on that, we will get a different block in the office. So then the same top, left, right, etc. So it's similar process for all the objects, and the same for the rest of the elements. So type of staircase is single, is dogleg. You see the points that we need to measure to define the door, the staircase, etc. So there are a lot of functions to enable you to measure the elements. The same for columns and beams. So if it's rectangular or if it's circular, and also very easy to measure. I just measure 3 points here. You see, first point, second point, third point. And we also choose the material. Depending on what we are choosing here is what we will get automatically later on in SketchUp. So the proper texture. So second point, third point, and after that, if you want to copy the same column inside the room to another column, we would just need 1 point for that. So and so on. So you can continue using other functions for heating, for symbols. So you see here we make use of the great functionality inside TBC of blocks and symbols with 1 point, 2 points, or 3 points insertion. So you see here in this case 1 point for the insertion and the second point for orientation and scaling. So we would see it here with different colors, or for the bath tube. So we would need the 3 points, and so on. So we continue, etc. And once we have finished the measurement, we just need to export it as job XML. This is TBC12, and that's it. So later on, once we are ready, we can go to TBC, for example. This would be the first step. We just open a new file, and we just show the 2D on the left and the 3D on the right, and we just drag and drop the file that we just created. So let me check. It's here under export. So this is this file, TBC12. We just drag and drop. Okay. So we have on the left 2D, on the right 3D. And as I said, just with 3 clicks with the code processing, 1, 2, and 3, we get first the 2D on the left with area calculation, with perimeter, with the proper block for the door, with some additional information and as annotation, with the width, the height of the door, etc. And also this is customizable. So each customer can use different libraries, so to use different doors, different colors, different layers, and at the same time you see here the 3D representation is created. So it's a very small example that we just measure in within a couple of minutes, but obviously we can also import a biggest example just to show you that the way is exactly the same and as simple and as quick as we have seen. For example, this one is the office, the whole office where I am. Yeah, I needed like 1 hour for the measurement with the total station, and you see how quick the 2D and 3D creation works with TBC. So we import it. (2D, 3D), and I just hide the point IDs so we can see it a bit better. And then again 1, 2, and 3. So we have a 2D here also, which each single room area calculation, etc. So annotations, and also the 3D here. So it's very quick, I know, but so very fast explained. But I think so because we have to show a bit more, and we are pretty bad in time. So we could export here from here to DWG, for example. So we can choose all the elements, and we just choose here the one local folder and say Office 1, and we also export it to SketchUp. So we see how it's coming to different software packages. So everything the same, and also to SketchUp. to the same folder, Office, export. So we can open it already inside AutoCAD. This one that we just created. So you see that everything is coming so one-to-one. So what we have seen inside TBC, and it's also a 3D WG that you can deliver to your customer. So you see here also in the cases where we said the windows have two panels, etc. So you can deliver this as a solution, as a finished drawing to your customer. The same would happen inside SketchUp. So we can open SketchUp, the SketchUp file that we just created from TBC. So we go to the file there. This is the Office 222. So we have the 3D representation, and if you need a bit more 3D definition, you could simply create your walls this way, and pretty easy finish your drawing, creating the parallel walls, etc. So you could use the reference lines for the widths, etc. You could import and insert your doors, windows, etc. And the same would happen even inside Revit if you need it. So we can go to Revit here and just import the same DWG, and then with this reference we could start picking the walls, the windows, etc. Okay. So I just open a new file. I link the DWG that we just created from TBC, and we see how quick it is. So we link the CAD file, this one. So we have it in the drawing. So we see it there, and then we just need to create 2 levels to create the walls, and that's it. So we can start doing the rest. I just create it approximately just to show it very quickly. So we change to the 3D, and then we use the existing elements to create the walls, for example. So we just pick on the elements from level 3 to level 4. So you see here that we could simply create the walls, etc. So we could use the whole functionality just picking the elements that we created in TBC. Okay, I think it's time. We are pretty much behind the time. So I would just move to the same would happen inside SketchUp. So the automatic creation of the 3D model. So then I would like to continue with the summary. So please, no fear of 3D and BIM. So there is a huge business out there for surveyors, not only for BIM, also for 3D modeling. And we have some tools to support you. And there is also a solution and workflow for each need. So the entry into the 3D and BIM world is easier than expected. So therefore, Trimble, your local Trimble dealer, and Calvo Geospatial support you all the way. I think so. We have now more or less 10 minutes for questions and answers. Joe, Boris, it's okay, or?
Yeah, absolutely. Do you want to do the first few slides?
Yeah, since we're in the Q&A period, we can do some questions. I'll do resources at the end, some follow-ups.
So question from Manuel Fernando is the LOA in direct relationship with the tolerance or precision?
Exactly. This is exactly the precision that is requested for the data that you are providing. So the global accuracy.
Dennis is asking, is there a roadmap to directly import IFC files in Access without having to have TBC or SketchUp in between? I know it's a really hot topic for Trimble Access team, so I cannot commit to any timelines, but there definitely is desire to support more of IFC and models in the field from Trimble Access perspective. Stephen is asking, Fernando, when you're measuring an opening, is it possible to measure the symbol key points, like those red dots, from different setup locations, or is it necessary to measure from one setup location?
For the openings, you need to measure with the current measure mask. So once you leave the current measure mask, the data is lost. So for one opening, one door, one window, you need to do it from the same station point.
Okay. Clay is asking, will the process work with the SX10 total station, scanning total station, or just with regular total station?
Yes, it's also with the SX10. So all S series, the M3, the C5, so all Trimble total stations.
A couple of questions, Fernando, have come in. Interest around your FXL library and creating those 3D elements. Were you able to extract and generate the 3D elements off of coding from the FXL coming from Jean-Michel and Babak in Canada?
I would need to check it because in the FXL you are only supporting 2D blocks and symbols, and you can define the insertion points, etc., but not the 3D definition. It's created in Revit, in SketchUp using the plugin. So you could also personalize your blocks that you can use both in TBC and SketchUp. So using this plugin, you can just import, you can just create these 3D elements for doors, for windows, etc. So I show you one example what the plugin creates, but not the answer for TBC is not at the moment. But I'm writing down this information, so probably I can check if there is some way to create also some similar results. So this is what you get automatically from the plugin. So you see here, so the doors, the windows, I'm in this room right now. So everything is created with a proper symbol or proper 3D component, and you could also customize it to your needs, but not in TBC. I will check it if there is a way via the FXL file.
That SketchUp plugin, does it require a specific edition or version of SketchUp to run?
If I have tried from 2015 upwards, so 2015, 17, 18. I didn't check myself on Mac yet, but it should work. So I have to try it on my own, but it should work at least from 2015, and I will check if we also support older versions.
Thank you. It looks like Sandro is asking. Looks like Fernando is running SketchUp Pro.
Exactly, yes, because SketchUp Pro is the only one supporting plugins, external plugins.
Fernando, have you worked at all getting this data into Vectorworks? Questions
yes.
from him?
Yes. You can both the DWG that you created with TBC, the same as I showed in Revit, or you can even create this 3D model inside SketchUp and just loading the SKP file, the SketchUp file inside Revit, Vectorworks, ArchiCAD, Nemetschek, Allplan. So almost all these software packages support the direct link of SketchUp files.
So, Fernando, is there a way for our users or participants, some of them are interested in kind of getting some access to the data sets where they can play with this? Is it possible to share some of this?
Sure, I can place a link on our web page. So with some data sets, this building, this office, and some others that we measure ourselves, so it's not a problem. So we can provide the job XML file.
Okay, and that is a good transition into kind of the next step. There are a handful of questions here still unanswered. We've got them logged, and we can get back to you in a timely fashion. But what Fernando mentioned, thank you, Fernando, for sharing the data and sharing this presentation with us. This recording will be available for you to view at a later time. With that recording, we'll send out the presentation, if that's okay with Fernando, as well as the data. So there have been a couple of interested questions on demoing and working with this data themselves. So it's good. We're stirring up some interest here.
Excellent.
I just got a few minutes of next steps slides here.
Yeah, sorry.
Yeah, no problem. Resources for TBC. So if you like what you saw from TBC, we've got our new webpage, trimble.com/TBC. Right at the top, you can download the latest version, which is version 4.00. The CAD and COGO functionality that Fernando showed would be included in TBC Advanced Edition. Go ahead. And then hopefully you're interested in the new, or newish, I should say, Trimble Access Buildings application. That is distributed like any other Trimble Access or Trimble Access app through your Trimble distribution partner, and it is deployed through the Trimble Installation Manager, again, consistent with any other Trimble Access application.
You do need to contact your Trimble geospatial distributor for the license, right?
Yes. Okay. Additional TBC resources. We've got a thriving TBC YouTube channel to check out, the TBC survey.
So Fernando, you have videos on YouTube as well?
Yes, exactly. So about the main steps. So for the Trimble Access app, for the SketchUp plugin, etc., and some examples.
Excellent.
Do you know the name of that channel offhand?
It's Calvo Geospatial.
Calvo Geospatial. Okay. Thank you.
Welcome.
Like I had mentioned, this and any other Power Hour, we've been doing this for over about 3 years now. They're available at no charge to go back and watch at your own leisure. We've been adding this presentation and the data sets were applicable here lately. So this presentation, this recording, and the data will be available. By registering for this session, you'll get a notification when it's available. We've got our public-facing Trimble community page, a great way to interact with myself, with Boris, with other members of the TBC team. If you have a question for Fernando, this would also be a great place to post. We really like seeing the community page take off because we're getting user interactions with each other. So users are answering user questions, really building the community around TBC. Next steps, so you can go ahead and download TBC if you don't have it already. You can get a free 30-day demo license from your local Trimble distribution partner. That same distribution partner will be able to assist you with Trimble Access and the Buildings application if you're interested. There's a new geospatial dealer locator, kind of a slick page. You can see we are worldwide. The next TBC Power Hour, last slide here, I want to tease this, will be on Tuesday, not Wednesday, Tuesday, March 27th, on going through COGO and point creation tools and routines in TBC. There's been a lot of questions on, hey, we love the functionality of Trimble Access COGO routines. How come you don't have that in TBC? Well, actually we do. We make it fun and adventurous for you in the Create Point icon, ribbon icon. If you click on the little down arrow, you see all of these different routines. Fernando showed a couple of create points from CAD objects routines. There's best fit routines. So going through that, and may recruit the help of Boris here. Really a very educational, a lot of kind of quick hitters for creating points and coordinate geometry in TBC next month. This will be on Tuesday. Apologies for the change. Tuesday, March 27th. And that is all I have. Again, thank you to Boris and Fernando. Do you guys have anything to wrap up?
As Fernando said, please don't be afraid of 3D and BIM, and take it as your advantage. There's a lot of opportunity out there. A lot of general contractors are still kind of getting their heads wrapped around this as well. So nobody knows everything. Everybody, the industry is in process of learning. So take advantage of that to be first, to establish yourself and your business, and grow your business in building construction and BIM.
Yeah, also thanks so much from my side to Boris, Joe, and for all the attendees. I hope that you could pick a couple of ideas that can help you for your daily task. Thanks so much.
Thank you, Fernando.
Cool. Thanks.